Hey everybody, I'm Zach Bowman and I designed and developed this small game. Well, design is a loose word. It's a copy of Boomblox on the Wii. Loosely a copy. I took a few liberties. Now, I did all of this in Unreal 5. Now, the idea here was to see how quickly and how efficiently I could prototype a very small physics-based puzzle game in Unreal as opposed to something else like Unity, for example. I decided to use blueprints, and I still believe that was the right decision. Using blueprints, I always think it's going to save me all this time. It still takes 75% as long as if I had just done it in C++. One of the most noticeable features right off the bat with Boomblox is that it's a physics-based puzzle game in the sense that you don't have a player that walks around. We're not bipedal. It's not a first-person shooter or a third-person adventure game or something like that. We have a central stack of items we're working with, and we want the camera to pan around so we can see the room, see the puzzle, interact with it from different angles. It is first person, but we don't necessarily want first person controls. Yes, there are examples like Portal, Superliminal, a great game actually made locally right here in Seattle, Jonathan Blow's The Witness. They all use some version of vaguely first-person shooter type controls. I decided early on this game would have to be a little bit different. Early on I made a judgment call and I decided that we should restrict the player's movement to a circle around the central puzzle and have them always look at it. There were other possibilities I considered. I thought about allowing the player to look around the room while also moving, and that's an interesting proposal. I think a great thing to do would be to let the player look around freely, but then when they try to move, the camera smoothly moves back to look at the puzzle, with interpolation, of course, not in a jarring way. I was also worried that if the player was looking at something else, not the center of the puzzle, any other direction, and then they started to move, and they started moving in a circle, that it would be a little disorienting, perhaps a little, nauseating. It just seemed like potentially bad UX to me. There are a lot of really cool features I would have added for more like a final product. For this tiny prototype, a lot of things got skipped. We don't want to spend a lot of time on this. Now, rather than make the player their own entity separate from the puzzle itself, I decided to place a puzzle origin at the center of the room. This is where the puzzle will be built, and it's also where the player's actual point of origin is. The camera is attached to a spring arm on the player blueprint, and then when the player moves, I'm just rotating the spring arm. Actually, I had to put this pretty far out. I was surprised at how long I had to make the spring arm in order to get the view that I wanted. The player controller actually ended up being the most complicated blueprint. Not that there isn't a good amount of logic in the other blueprints, but I would say more than half of the game code ended up right here. Now, once I got player movement handled, I really quickly realized since we're not doing traditional mouse look, the player is no longer in charge of what they're throwing the ball at. So the cursor can't stay in the center of the screen. If we're not going to have traditional first-person shooter controls, we can't have a traditional first-person shooter crosshair. The player needs to be able to visually indicate on the screen with the mouse what part of the screen they're going to throw the ball at. We're either going to have to let them turn their head, or we're going to have to shoot from the mouse cursor and not from the center. We have get mouse position, and then deproject screen to world. Transforms the given 2D screen space into a 3D world space. Let's talk about block inheritance. I knew the puzzle was going to have 3 different blocks. One that is static and essentially part of the room geometry. One that is a physics object that will fall over. And then finally, the goal block itself. I decided an easy way to do this was to have a base cube that was immovable. I decided to make it concrete. And it turns out using inheritance from the concrete to the wood to the glass actually helped me out a lot later, even more than I thought it was going to. It was important to me that the wooden block went flying when it got hit by the projectile. I thought that was important to the fun factor. This code is here to make sure that the wooden block actually goes flying when the ball hits it. Yes, it has physics enabled, but that didn't mean that the block would actually move on impact. And here's our goal block, also known as the glass block, which does everything the wooden block does, but also shatters. I wrestled back and forth a bit with the decision to put the collision logic in the ball versus in the block. This is, I think, where we get into design decisions or architectural design decisions on the engineering side that can affect the larger project. Even though this is a small prototype and I'm not taking it any further than that, I also pretended that this could potentially be a bigger game. What if I actually wanted this to become extensible? Will it scale? I decided it's a lot more likely that a theoretical final product is going to end up with a lot of different block types, a higher number of block types than projectile types. Let's say that. In a big game with 100 levels or more, of course we're going to introduce new gameplay mechanics along the way. Therefore, if we put all of the collision logic inside this one projectile, this event graph is going to become enormous. It will scale better with the collision logic in the block. One major problem that I ran into while I was working on the block collisions: how do we get the glass to break when the puzzle falls? If we have a wooden block and we hit the wooden block out from under the glass block, don't we want the glass block to fall and break? That should count. In going through all of the scenarios where I did and did not want the glass to break, I came up with 3 situations. The first is a direct impact from ball to block. Player throws a ball right at the block, shatters. Awesome. Second scenario is gravity. If the glass block hits something else and it's going above a certain velocity, it should break. And the third scenario is another block hitting the glass block. I ran into a lot of problems with this, so many little edge cases that at first I couldn't resolve it, and then it dawned on me I needed to keep track of multiple velocities. Things get more interesting when we start having blocks hitting other blocks. For example, if I shoot this wooden one in the center, my expectation as a player will be that I'll shoot the wooden block out from the middle of the stack. This glass block will fall onto the other glass block and they'll both smash. And it does. Boom, there you go. Now this doesn't always play out the same way every time because of physics and just random chaos. The problem I ran into is with the complexity of these different situations and dealing with different conditions. And a key thing here is I had to separate these two. Originally, I had this as one value for just a minimum break velocity. I was running into problems with, for example, shooting this middle block, the wooden one, and then having the glass block above it break, or having the one below it break. And the reason that was happening is if we shoot this wooden one and the wooden one starts moving at a certain velocity and it's still touching the other two, technically that counts as a collision. Then it does the velocity check and says, oh, those should break. My thought as a player was, no, I don't expect that to happen. I expect to be able to shoot this out and have the top one fall down and hit the bottom one and then break. Let's talk about the warm-up, or the delay between shots. I thought it would be cool if the blocks kind of tumbled in when the puzzle starts, but I wanted to give the pieces a chance to settle and stop moving before the player is able to throw the first ball. There's a potential issue if the player throws a ball before the pieces stop moving. In the goal block logic, there's a check to see if the first ball has been thrown. Without this check, what happens is when the puzzle starts, the blocks tumble in, they hit each other, they break. The player wins without having thrown any balls. You get a score of 0. Another cool thing is I ended up using this warm-up to limit the player between shots. The player's not able to bang, 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 shoot a bunch of balls rapid fire. It's not a first-person shooter. It's a puzzle game. I wanted a slower, more meditative flow to it. The final piece to this was, of course, doing the block reset. I thought about a few different ways this could be done, and my first knee-jerk response was having some sort of a state that all of the blocks are spawned from. All the blocks could be spawned procedurally when the game starts, based on some pre-existing puzzle state that is supposed to be achieved. Maybe that would be a good idea if we were making a big game with like 100 levels and we had some separate level editor that designers were using and we wanted to load the data from that. This is just one level, and it just seems like overkill. Sometimes you don't want to kill a fly with an anvil, and I decided instead of destroying the blocks, why don't we just keep track of where they were when the level started, and then when they get destroyed, technically we're not actually destroying the actor, we're just hiding it. We make it invisible, we take away the physics, and we allow pass-through by changing it from block collision to overlap collision. What I thought was going to be the most difficult feature actually ended up being the easiest, quickest thing. There is a slight bug that happens with the block reset, even though I'm putting the blocks back where they were, same position, same rotation, and I'm killing their velocity. They often come back if you do it fast enough, especially if you hit the reset button while they're falling. They come back a little funny, and the stack wobbles, and I think perhaps the reason is because I'm setting the linear velocity to 0, but I'm not doing anything with the angular velocity. If the block is spinning, it kind of spawns in still spinning, which is why some of these rotations are crooked. We wouldn't want to ship with a bug like this in there, but I would say it's a low priority thing. This project, I think, started out slow. I had some trouble in the beginning, the first few hours, especially with the fact that I used a blank project instead of using one of the templates. None of the templates fit. First person didn't seem right, third person didn't seem right. Starting with a blank project ended up having some of its own difficulties. It seemed like there was a little bit more boilerplate than what I was expecting. Altogether, I had a lot of fun working on this. See you guys next time.